My name is Skylar Smith here at Apogee Instruments, and today we're going to talk about choosing the right quantum/PAR sensor. We're going to talk about what do quantum/PAR sensors measure, our original versus full spectrum sensors, the difference between all the models we offer, the output options available, and then we're going to talk about our USB output options and how those are different. So first off, quantum sensors measure PAR. PAR is defined as photosynthetically active radiation. And we measure PAR in units of micromoles per meter squared per second. So these are the 5 different series we offer. The 100, 200, 300, 400 series are all in the black and have the black head, have our original spectral response. Then we have our full spectrum over here that have the full spectral response. And we're just going to touch on that here in a minute, but here are some references for you. There's a great video from our CEO, Bruce Bugbee, and it's going to give you an in-depth explanation of what PAR is. And you can click on all these links in the comments section below. We have a great link here that talks about the spectral errors by light source. And again, you can click on that in the comments below, but that's going to tell you, based on which type of sensor you go with, whether that's the original or the full spectrum, based on what type of light you have, what type of errors you would expect. And so, of course, with the full spectrum, those are going to be pretty small errors compared to the electric or sun calibration. And then we have a link here as well that just compares all of the sensors together. We're going to show that table later in this video, but if you want, you can just click right there to see that on the website. So, full spectrum versus original spectral response. Now, first we need to define PAR as how the plant sees light. And we can see that is the dashed line here from 400 to 700 right here. So ideally, that is the spectral response a PAR sensor would have. So we're not able to get that with our sensors. And so our original one, you can see it cuts on right here, cuts out a little bit of the blue, a little low on blue, and then it completely cuts off some of that far red above 665. So with that, we calibrated according to sunlight or calibrated according to electric light sources, and we have those 2 different options available. Then we came out with the full spectrum sensor, which more closely matches that PAR response, and so that one's going to give you much more accurate readings for all light sources. So the SQ100 series. So this one, the SQ110 is calibrated for sunlight, the SQ120 is calibrated for electric lights. Electric lights meaning your high pressure sodium, your metal halides, your T5 cool white fluorescents. So it's not great for red LEDs because of that spectral range we talked about on the graph before. It's self-powered, meaning you don't need to add an additional power supply. You just need to hook it up to a single-ended or direct differential reading on your logger, and it will give you an output from 0 to 800 millivolts. And that range is equal to 0 to 4,000 micromoles. And so our factor for every sensor we send out is 5 micromoles per meter squared per second per millivolt. And that's for the SQ110 and 120. And again, that link right there, it's the same link as the page before. Our SQ200 series, and this just takes that same sensor and amplifies them into a voltage that you can use on your logger. The 212 and 222, 0 to 2.5 volts, 215 to 225, 0 to 5 volts, and 214 to 224, 4 to 20 milliamps. And then the same thing, the 210s are for sunlight, the 220s for electric lights. I do want to mention, same thing, these all need to be powered in order to get that amplified output, so it needs between 5 and 24 volts. Whatever you have in there, if you have 12 volts, great. It will automatically regulate the sensor and then give the output accordingly. So these are just some of your applications that you might be using these for. Greenhouse nursery, growth chambers, under canopies, aquariums, freshwater and ocean, underwater environments, and any measurements with your traditional grow lights, as we mentioned before, metal halide, T5s, high pressure sodium. The SQ300 has the same sensor as the 100 and 200. We just put it in the light bar so you can get your spatial averages. The 310 is for sunlight, the 320 is for electric, and then you can kind of see the breakdown here. The 313 and 323 is 3 sensors spaced over 50 centimeters. The 316 and 326 is 6 sensors over 50 centimeters. And the 311 and 321 is 10 sensors spaced over 70 centimeters. You can use it under canopy to see how much light is filtering through, given that spatial average, or on a bench, or pretty much anywhere if you want that spatial average. And again, we're just going to touch on that. We've just been talking about the original sensors, or the black line for the spectral response. Now we're going to talk about the full spectrum, the SQ500 series. And we actually only have one sensor in this series. It's the SQ500. Has that wider spectral range. The signal itself is much smaller. It's only 0 to 40 millivolts. So that puts 100 micromoles per meter squared per second per millivolt. So make sure your data logger or whatever you're using to read this can read that small signal. And then the output range is the same, 0 to 4,000 micromoles per meter squared per second. So accurate with all light sources, including all LEDs, to give you those accurate PAR readings. And so again, you can see just a couple of applications. Everything that was on there before, but especially with all LED lights, even those narrow bands, it's going to give you accurate PAR readings. This is that table, and what this table shows you is how each sensor measures up to the next one or compares with the one before. Really, let's just go across the output here for the sensitivity. You can see 0.2 millivolts per micromole per meter squared per second for the 110 and the 120. 1 millivolts per micromole per meter squared per second for the 212 and the 222. For the 214 and 224, you can see this is milliamp per micromole per meter squared per second, and that's 0.0064. And then the 215 and 225 is 2 millivolts per micromole per meter squared per second. The 300 is the same as the 100, where it's 0.2 millivolts per micromole per meter squared per second. And then the 500, that really small signal, 0.01 millivolt per micromole per meter squared per second. So you can pull this up on the website and look at it yourself, see if the specs meet what you're looking for. The SQ420 and SQ520 both have a USB output. So the 400 being the original series, the 520 being the full spectrum series. It does require a computer or tablet to display the output, but one of the really neat things here is you can set it up on the computer, sampling interval, logging interval, unplug it from your computer, and then take it and set it up in this type of application where you're just powering it, and it's going to log those readings that you set up in the head, up to 10,000 of those measurements. And then next time you plug it into your computer, you'll be able to take those readings in a CSV file and analyze it and look at it. I also want to mention that this is written in an open software, so if you're some sort of system integrator or someone who would just like the command codes to integrate it into your own software, just email us at tech support and we'll work with you on that. This is just an example of what the Apogee Connect software looks like. You can see our instantaneous reading right here, and then you can see our reading here. We're just logging it right on the computer, doing 5-second increments right here. And then we can see where it's being saved right here in a CSV file. This is just a couple of applications, just going back through. You know, you can see our sensors here in a greenhouse, where you might use them, the LEDs where they might be used, out in the field as far as a line quantum. Well, thank you very much for watching. Feel free to comment below with any questions you have, and we'll get back to you. Also, you can send us an email, and don't forget to subscribe to our channel. Thank you very much.